Welcome back to All This Math. This is Professor Parker, and right about now, we're about to do some work with solving quadratic equations using the quadratic formula. Now, I guess we don't have to use the quadratic formula. I guess we could complete the square, but when given the option, personally, when given the option of either using the quadratic formula or completing the square, I usually go with quadratic formula, unless I'm just in that type of mood and I just want to complete the square. Because quadratic formula is usually more straightforward, usually it's easier, depending on how the equation looks in the first place, you know. But let's first read the problem though. Let me start over. Let me run it from the beginning. What are the roots of the equation x squared plus 12x plus 61 equals 0 in simplest a plus bi form? So first off, we got to make sure we know all the vocabulary. Roots. What is a root? And what is a plus bi? What is that? So a root basically is a solution, right? A solution, an answer, an intercept, an x-intercept. It's a value for x that makes this a true statement. Because remember, math is all about finding the truth, all right? Now, correct answers give us the truth. So once we find a value for x that's true, then that means we should be able to substitute that value in for this x, and then do the mathematics following the order of operations. And the whole left side of this, once we do all the calculations, should be equal to 0, right? If it's a root. So that's what a root is. When you see that term root, in some contexts, it means like a square root or a cube root, but also it means an answer basically, or a solution. Also, simplest a plus bi form. So a plus bi form is just a form of writing an expression that includes an imaginary number. So a would be a real number, b would be a real number, but then I would be an imaginary number. So this is a hint that our answer is going to have an imaginary number, right? You know, imaginary numbers is like he's all right, but he's not real, right? Imaginary numbers are like numbers like the square root of -1 or the square root of a negative is an imaginary number. Like it's a number that we have to deal with. It's a value we have to deal with, but it's not real because in real life, in reality, you can't multiply any number by itself and get a negative. So like, that's why you can't take the square root of -9, right? You can't take the square root of -9, right? Because 3 times 3 is +9. And also -3 times -3 is also +9. So there's no way in a real number system you can multiply two numbers, the same number by itself, and get a negative result. It just can't happen according to the rules of the real number system that we follow. All right. So we're going to deal with what's called an imaginary number. An imaginary number is used to represent those situations when you end up with the square root of a negative number or -1. All right. So look, let's use the quadratic formula for this. Now, the quadratic formula is something we should have memorized. If you don't have it memorized, cool, you should look it up, right? And eventually, you should set a goal to memorize it. All right, so the quadratic formula looks like this. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now, that's the quadratic formula, right? That's how we solve for x. We replace the letters b here, a here, c here, and a here with coefficients and constants from the equation or from the expression that we're given, right? But also the equation must be in standard form. And this is given to us in standard form. So we got a 0 on the right side and everything else on the left side. That's a key point. You can't label A, B, and C until the equation is in standard form, which means everything, basically all the X's and the non-zero numbers are to the left and you got a 0 on the right. All right. So what we could do is this. We might as well just label what A is, B is, and C is. So in this particular problem, A is +1, and B is 12, and C is 61. Because A is the coefficient of your x squared term, always. B is your coefficient of your x term, or your linear term, always. And C is the constant. The constant doesn't have a variable attached to it. So you got your A, your B, and your C. And if your equation is in standard form, meaning your exponents are in descending order, then the values of A, B, and C should go in order. 1, 12, 61. 1, 12, 61. And those are some of the details that are very important, right? Because if you skip over those details, you're going to get these problems wrong all the time anyway, right? So you got to know what A is, B is, and C is when you're looking at one of these problems. All right, now, we could just jump in and go into the quadratic formula, but this is what I like to do. I'm going to tell y'all a trick. This is what I like to do, right? I play like a mental game with myself. What I do is I find the discriminant first. Now, the discriminant is this part right here, b squared minus 4ac. That's the part under the radical sign, right? I like to do that first because it makes me feel like I'm breaking the problem up and I'm making the formula shorter, even though I'm really not. I'm doing the same amount of work, but it's kind of like, I don't know, I don't know. It just makes me feel like I'm doing less work. So it's something I started doing like years ago and I just stuck with it. So what I'm gonna do is I'm gonna find the discriminant, right? B squared minus 4ac. I'm gonna calculate that. I'm gonna get a number. And then I'm gonna take that number and I'm gonna throw it into the formula. And then when I do the negative b plus or minus and the divide by 2a, I'm gonna be doing less work when I get to that point because I've already done some of the work. So I'm gonna find the discriminant. Now the discriminant is, like I said, b squared minus 4ac. What does the discriminant do? The discriminant tells us how many real number solutions we're gonna have, whether we're gonna have 2, 1, or none. If it's a positive discriminant, we're gonna have 2 real number solutions. If 0 is the discriminant, we're gonna have 1 real number solution. If the discriminant is negative, we're not gonna have no real number solutions, and we're gonna have 2 imaginary number solutions. All right. Now, let's do b squared minus 4ac. So b squared minus 4ac is gonna be equal to 12 squared minus 4 times 1 times 61. So you see, I replaced the b with a 12, the a with a 1, the c with a 61. All right, so I got my equal sign. Now, 12 squared is not 12 times 2. It's 12 times 12. 12 times 12 is 144. You got to know your multiplication facts. 12 times 12 is 144. All right, now over here, minus 4 times 1, that's negative 4. Negative 4 times 61 is negative 244. Negative 244. So we got 144 minus 244. So negative 4 times 1 was negative 4. Negative 4 times 61 is negative 244. Now we're going to do subtraction. See, we always do an order of operations. Then we're going to do subtraction. 144 minus 244 is negative 100. So because my discriminant is a negative number, I already know I'm going to have 2 solutions that are imaginary. They're not real. They all right, but they're not real, right? I'm going to have 2 of them because my discriminant was negative. So now I'm going to go back over here to the quadratic formula, and I got x equals negative 12 plus or minus the square root of negative 100 all over 2 times 1. And then I got negative 12 plus or minus. Now, let me show you what's going to happen. This is how we deal with imaginary numbers. This is how we get imaginary numbers. This negative sign really represents a negative 1 being multiplied by 100. So let's think about it like this. Negative 1 times 100. And then my denominator is 2 times 1, so that's 2, right? Now, the square root of negative 1, that's going to come out of the radical sign and become the lowercase I. The letter I stands for the word imaginary, an imaginary number. So that represents an imaginary number. So the negative 1 comes out. Now, 100 is a perfect square also. So that's going to come out the radical sign too, because the square root of 100 is 10. So the square root of a negative 100 is 10i. Because the negative 1 part, which the negative sign represents a negative 1 that's being multiplied by 100, is going to be lowercase I, which stands for the word imaginary. And the 100, the square root of 100 is just 10. So now we got negative 12 plus or minus 10i all over 2. Now this is why they put the part of here, simplest form. Because you can't, somebody might be tempted to stop right here, but like, all right, this is my answer. I'm done. It's a wrap. It's not, you're not done, because this can be simplified. Because remember, we can divide both of these numbers by 2. Because think about it like this. These can be separated into 2 separate fractions, right? Negative 12 over 2, we could also write it as negative 12 over 2 plus or minus 10i over 2. And if we saw it like that, then we'd be like, oh, then you'd be like, oh, okay, I get it. Yeah. But you got to have you got to understand how to recognize that when your denominator is a number, and both of the numerators, both of the numbers in the numerator, are divisible by that number, then you can reduce. So negative 12 divided by 2 is going to be negative 6. 10i divided by 2 is going to be 5i, because 10 divided by 2 is 5. So that's 5i. And you can't combine these two, right? Because we can't, because that's an I. That's imaginary. So this is an imaginary number, 5i. This is a real number. So this is real, this is imaginary. They're not alike. You can't combine those. You can multiply them together, but you can't combine them. You can't add or subtract them. So this is the final answer. And this is actually the roots. Notice that this is plural, more than one. The one root is negative 6 plus 5i. The other root is negative 6 minus 5i. That's what that plus or minus sign represents. See, plus or minus, right? Instead of having to write negative b plus all of this divided by 2a, and then negative b minus all of this divided by 2a, we just write the plus or minus symbol and we just consolidate like that. All right? So that's how I use the quadratic formula. That's how I use the quadratic formula. You know what roots are now. You know what a plus bi form is now. You know what imaginary numbers are. You know how to find them. You know what they look like, right? You know what situations you're going to encounter them in. You know how to use the discriminant to make it seem like you're doing less work, even though you're really not. You know what I mean? You know how to identify A, B, and C when you're using the quadratic formula or going to be using the quadratic formula. So you learned a lot. All right. But as I always say, go get some practice. Ask your teacher, ask your professor, go to your textbook, or go online and find some examples that look like this, where you have to use the quadratic formula and you will have an imaginary roots, right? In the form a plus bi. All right? So go get some practice. I'll catch up with you on the next video. Peace.